Hello everyone, we'll start our course Corrosion Protection Methods. This particular course series, the series of lectures, will talk about different methods that are existing for the protection of metals and alloys from corrosion related degradation. And you will see that many of the cases you have to first understand the problem and then you have to decide the protection methods. And while deciding, couple of things you need to consider. The first of all is the economic, whether that method is economical, that means cost effective. At the same time, it should be effective in giving you protection for the time duration you want. At the same time, that process should be such that in case some changes are to be done, we should be able to do that without much of difficulty. So, we will discuss all those things one by one and different methods that are existing. We will discuss those too with specific examples. So, the course is on corrosion protection methods, and this is the first lecture. And there will be 40 lectures and each lecture will span of about around 30 to 35 minutes. And the topic for today is we will discuss bit about corrosion basics. Okay. Now, as we have seen, we have been deliberating on different aspects of corrosion, like the definition of corrosion, then the mechanism related to thermodynamics, related to kinetics, as well as different forms of corrosion. In fact, we have also talked different environments, and later we have shown that there are some case studies, and depending on the case studies, we have started showing that how to attack a corrosion event and resolve that problem. But now in this particular course, little bit we should get to the basics of corrosion, and then we'll list down different environments as well as different factors which are actually governing the corrosion pattern or corrosion severity in a metals and alloys component. And in fact, why we need to mention those? Because if we understand those parts carefully, then the method what we'll choose or the method what we'll design for the protection will be very easy to find. Okay. So, we just talk very briefly on corrosion basics. For greater understanding, you can go back to our previous lecture series. Now, when we talk about corrosion, it's a degradation process, and when we talk about the degradation, we will concentrate on metals and alloys. That means engineering components made out of metals and alloys. There are components like ceramics, made of polymers. We will not get to that part, but we will concentrate on metals and alloys part. So, if we see the typical definition of corrosion, as per our understanding goes, it's basically electrochemical interaction between metals, alloys with its environment. And this environment can be of varied nature depending on the location, geographical location, depending on the typical atmospheric or soil or electrolyte condition or aqueous medium condition. We can have varied nature of this particular environment, and the same metal or alloy can interact differently. So, this electrochemical interaction is the major part, and the other thing that can come up, chemical interaction. So, that means where we do not have any electron exchange process. So, this particular thing would actually enhance the dissolution process which is happening due to the exchange of electron. And there could be other factors like stress, like surface condition or material composition or structure. And the structure could be of atomic structure, it could be of microstructure and even macrostructure. Okay, so those will be the other factors that can enhance the electrochemical interaction. Now, this is the basic part. This particular thing is the basic, very important part. If we do not have electrochemical interaction and the dissolution or the degradation of metal, we would not term it as corrosion. Okay. So, let us get to that part little more so that it becomes clear to us, and since why this is important to understand this, so then only we will be able to judge the protection routes. Now, when we talk about electrochemical interaction, we have to have 4 components. The 4 components, what are those components? One is anode, where anodic or oxidation process happens, and which is nothing but, let us say, a metal iron which releases 2 electron and goes to Fe++. So, wherever this ion forms, that has the ability to dissolve in electrolyte like aqueous solution. So, actually the corrosion is, or the degradation is nothing but this, that means the loss of metal in the form of ions. But if we have these 2 electrons which are released by the iron atom, that 2 electrons must be consumed, and that consumption of that electron happens on cathode. So, cathode, it is basically cathodic reaction or a reduction process. And there could be several reduction process where electron is accepted, like oxygen reduction, and this happens when pH is greater than equal to 7 in the neutral or basic medium. Again, oxygen reduction can happen in acidic medium, where pH is less than 7, that means acidic. There could be hydrogen reduction, hydrogen ion reduction. It happens pH less than 7. Water reduction, it happens in neutral as well as basic medium. So, this is related to the dissolved oxygen that reacts and then cathodic reaction happens there, and everywhere you see those are electron accepting reactions, that means reduction process, and that way you are actually maintaining the charge balance. There could be process like metal ion reduction. There could be process like metal ion going from higher oxidation number to lower oxidation number. Okay. So, those processes can also happen provided those ions are present in that electrolyte, and if those ions have a higher reduction ability. For example, if we consider copper and iron, and we know there is a series called galvanic series, and in the galvanic series copper is sitting on top of iron, that means copper is a noble compared to iron. So, that means if there are two ions, copper ion as well as iron ion, the copper ion has the higher ability to get to copper by taking two electrons, and the reduction of copper ion would be faster or would be a greater possibility than the reduction of iron ion. So, these are the several processes. There are lot more cathodic reactions those can happen depending on the species availability, but basically these are all cathodic reaction which actually basically takes care of that, all those reactions take care of that electron, those are released by iron while forming iron ion. So, if you see this is let us say the iron surface. So, now iron ion goes out. So, this 2 electron. So, this 2 electron can go close to that particular dissolved site, and then cathodic reaction can happen. And this is anodic reaction. In fact, there could be a possibility of multiple number of anodic reaction as well as multiple number of cathodic reaction. There are presence of those elements, like let us say galvanized iron, we have zinc coating on iron surface, and if let us say zinc layer is little scratched, so that means you are exposing iron surface. So, then whenever there will be let us say water droplet on top of it, let us say this is my surface where there is a small scratch, this is a kind of zinc layer, and here iron is exposed. So, and if you have a droplet like this, so then iron as well as zinc both would form ions in the form of Fe as well as zinc by releasing 2 electrons. And of course, since it is happening in the atmosphere where the atmosphere is mostly neutral and water is present as well as dissolved oxygen can also be present. So, the possible reaction would be this one. Okay. So, this is the cathodic reaction, and there are 2 anodic reactions, and out of that 2 anodic reactions, the relative kinetics of those 2 reactions, anodic reactions, would decide which one would dissolve more at a higher rate and which one would dissolve at a lower rate. And generally when we have galvanic coating or zinc coating on iron surface and there is a scratch, that means the iron as well as zinc, that couple is there, iron dissolution becomes much less compared to the zinc dissolution, and that way we have galvanic protection of iron. So, this is actually iron protection route. In fact, how do we know? We know it from mixed potential theory. So, if you would like to get to that particular lecture, please go back and check those lectures. Fine. So, now what I mean to say that on anode oxidation process happens, or we can say this is nothing but the corrosion process. And in fact, if we see the cathode, if we can make something cathode, we see that cathodic reaction happens, no ion formation, no dissolution of ion from that portion. So, we can say that if something we can make it cathode, we can protect it. Okay. So, this is the basic principle for cathodic protection. We will check that later on. Now, these are the two components. Now, what are other two components? Since we said that there should be four components. Now, other two components are, one is electrolyte. Okay. So, this means this is, we can say 1, this we can say 2, this is 3. Okay. Now, electrolyte, what it does? It actually used for transfer of charge. Here the charge transfer happens via ion movement. And then the last one we need, which is conductor, which is fourth, transfer of, again this is transfer of charge, and there electron movement happen. And generally this conductor is metallic. If we see this particular example, you see these electrons are moving through the iron object. So, the iron object is acting like conductor, and then cathodic reaction, anodic reaction, all those things are happening at the interface between electrolyte and the metal surface. So, these are all electrolyte medium. Fine. And when we have this all four components, you see that electron is released here. The current is actually passing from, if we see the current is passing from the cathode to anode. This is the cathode part, we can put it as a C part, and this is A part. In fact, if you see the current flow happens from the C to A, this is circuit current, and through the electrolyte current flow happens from A to C. So, that way I get the completion of circuit. So, this is in a nutshell about corrosion process. And in the corrosion process, if you see that though this is my actual dissolution part, but on its own it cannot happen, it must be happening along with another cathodic process. And the other two components, conductor and electrolyte, are also important. For example, if we do not have electrolyte, definitely the circuit will be broken and we may not have anything of these particular two reactions. Electrolyte is important. At the same time, let us say the resistance for the electron transfer from the anode to the cathode, if that resistance is very high, again the rate of overall reaction would be reduced, and if the rate of overall reaction reduces, then the corrosion process also corrosion rate would also reduce. So, that means we have to have a complete process. So, this is the complete process, and where we have to have a reaction called redox. Why redox? This is the reduction process. For the reduction we take this part, and for the oxidation process we take this part, and then we are making it as a redox process, which is needed for complete corrosion to happen. Now, once we know this, in some of the documents you might find that it is mentioned that electrochemical / chemical process, but to me chemical process is basically a kind of a side process, and the actual direct process for corrosion is the electrochemical, electron exchange. So, now we have to also understand how this chemical process is influencing the actual dissolution process. Now, if we see iron dissolution in a crevice, So, what is crevice? Crevice is a sharp corner. So, this is a crevice, let us say. And now, in the crevice, iron dissolution happens. Now, I am talking about the later part of the reactions that are involved in crevice formation, and for that you please go back and then check the crevice process in detail. But here what I would like to mention is how come the chemical process comes into picture, which actually helps in greater dissolution rate of iron via electron exchange. So, when we talk about the iron dissolution in the crevice portion, in the later stage of reactions that happen near the crevice, we have this dissolution process, and we are talking about iron dissolution in crevice, and the solution is NaCl solution. So, that means we have chloride ion also. In fact, chloride ion does not take part in electron exchange process. So, what it does? Now, at the later process part that happens in crevice, so once this forms, it actually reacts with 2 chlorine ion and form iron chloride. So, now FeCl2 hydrolysis in presence of water, it forms the reaction happens like this, hydrolysis. Okay. Now, when this happens, what happens? We are forming iron hydroxide. Our iron hydroxide has a very low solubility, so it would like to settle down, and then we are also generating HCl acid. So, when we generate HCl acid, that means we are increasing the H plus ion concentration inside crevice. So, now if H plus ion concentration goes up, then the pH, if it is going up, so pH drops down, and when pH drops down, so that means even if this settled substance, and it can also get to, it can react with O2 and H2O and then form FeOH whole 3. This is a possibility. Okay. So, now I think this is balanced. So, this process can also happen if there are presence of oxygen as well as moisture, or water is always present, because this is the NaCl electrolyte, it means aqueous electrolyte. So, if pH goes down, the possibility of passivation goes down. So, that means if pH goes down, it actually hinders passivation. So, that means if passivation is hindered, we will always have active portion on the iron surface, and iron would always try to dissolve, because outside of that crevice the reduction process would be still going on, since this is neutral outside the crevice. So, this happens outside crevice, which is neutral medium. Now, this process is going on, so that means we need more electron, and here the inside the crevice the pH has gone down because of the generation of HCl acid, and then continuous dissolution would happen inside the crevice. So, that is what the crevice becomes autocatalytic in the later stage of its formation. Okay. So, now you see that this chlorine is actually not taking part in the actual exchange of electrons, rather it involves in a chemical process and that chemical process leads to increase in H plus ion concentration inside crevice. So, I meant to say that chemical process also would become important, but that happens later. The initial process or the corrosion, actual corrosion process is nothing but the dissolution by releasing electron by the metal atom. Okay. Now, this chlorine also has another effect. The chlorine also destabilizes passivity. So, if it destabilizes passivity, this is also becomes helpful for the continuous dissolution of iron inside the crevice. So, that is the effect of chemical reactions, which is the secondary, not the primary one. The primary one is always the anodic process, or this process is the primary one. This is the primary. And when we take it primary, this will be also part of the primary. Okay. And if we combine this, it is actually forming redox. Okay. So, now we see that chemical process is secondary in nature. Similarly, the factors like stress, this is also secondary. In fact, it can also act as primary depending on whether stress related fracture happens in the presence of corrosive. So, if you want to check the stress corrosion cracking, sometimes the stress initially activates the surface and the corrosion happens, and in another category where corrosion actually makes the crack or the point of crack propagation, and the stress actually opens up that particular point of attack. So, the stress here, the primary part is becoming when stress guides forming active site. Okay. But you will see that that is related to corrosion cracking. So, that time we can say that the stress guides forming active site, that was the primary consideration for that failure. But the corrosion, when the corrosion happens, so that time, since you are actually continuously having a stress in the component, it can actually help in active dissolution of the metal near the crack tip. So, but the corrosion process, when we see, it is always electrochemical in nature. So, that is what I wanted to mention. Now, why we discuss this? If you see that for our this discussion, whatever we have done till now, we see that of course metals and alloys, this is important. Then we have interaction with environment, and then we have, when we talk about environment, we are talking about different conditions, whether oxygen is present, chlorine is present, or chloride is present, or moisture is present, all those conditions. And then we are also having condition like stress. Here stress can come in, okay. And then finally we have electrochemical dissolution of metal leading to corrosion. So, now you see, if we have to have a proper idea about metals and alloys, we have to have a proper idea about environment, and then we have to have idea about stress. Now, two more things are very important, what we are not seeing in our discussion. What are those important factors? We have to consider the surface appearance. Why we have to be worried about it? Because the corrosion process always happens on the surface. So the surface could be rough, could be smooth, could have different patterns, and depending on that it could have different severity of corrosion. Now another factor that is important, we are not talking about the design or the geometry part. So the geometry part would also become important, because when we talk about, let's say, shape, if we have a crevice, there is the possibility of crevice. Now the immediate consideration comes that how to stop crevice is basically closing down the crevice portion, or we design in such a fashion that the crevice doesn't happen. Okay, so this geometry also would come in. Okay, so now these are the factors we have to know before we design some protection methods. And when we talk about these metals and alloys and interactions, here we are talking about interactions. When we talk about interactions, we should also have an understanding of electrochemistry. So if we understand electrochemistry, and depending on at what conditions we should choose a variation of potential of the metal to get a protection, and on that fashion we can design whether that metal should be protected via anodic protection or cathodic protection. So now you see, we can actually understand protection if we understand these many factors. So that's what I thought, that it's very important to have a basic understanding of corrosion briefly, and if we have to go to a depth of it, please go back and see other lecture series by me. So we'll discuss about this environment, metals and alloys and stress, surface appearance and geometry in our subsequent lectures. So till then, thank you.